this video, we'll explain how to determine if a function is continuous or differentiable. Okay, this is continuous. Okay, so for continuity, there are 3 steps you need to follow. First is f of a is defined. Okay, and the second step is find limit. Limit fx as approaches a exists. Okay, the third step is number 2 equals number 1. And limit fx as approaches a is equal to fa. Therefore, we can conclude that f is continuous at x equals a. That one for continuity at a point. Okay, if given want to show differentiability, okay, to show differentiability, you have 2 steps. First step is f of a is continuous. So from this part, okay, here f of a is continuous. And the second part is f prime of a is continuous. Therefore, we can conclude that f is differentiable at x equals a. Let's say this is f prime of x. Okay, this part is fx. Okay, this is fx, f prime of x. So, we can conclude that when f prime of x is continuous, it implies that f is differentiable. F is differentiable. Okay, when f prime x not continuous, it implies that fx so not differentiable. Not continuous for fx, f prime x, and not differentiable for fx. Okay, then for one is fx, and this one also fx. Okay, if f is continuous, okay, f is not confirmed differentiable. Maybe f is not differentiable or maybe differentiable. Okay, when f is differentiable, is confirmed f is continuous. The error goes to one side only. Okay, differentiable means continuous. For this one, f is not continuous. That is confirmed that f is not differentiable. And if f is not differentiable, f is not continuous. So this arrow goes to here and here, both sides working. Okay. Okay, example. Okay, given that f of x is equal to modulus x minus 1. And check continuity or differentiability at x is equal to 1. Okay, so for absolute value, okay, can be defined as this one, x minus 1 when x more than 1, 0 when x is equal to 1, negative x minus 1 when x less than 1. For continuity, okay, we need to follow the 3 steps. Okay, this is 3 steps. Okay, first is f of 1 defined. F of 1 is when x is equal to 1. Okay, f of 1 is equal to 0. The second step is find limit. Limit x approaches 1 from left. This one, okay, from left. Okay, the function is negative x minus 1. Substitute and is equal to 0. For limit when x approaches 1 from positive, we choose this function. So x minus 1, substitute and get 0. Okay, 0 is equal to 0 on the left is equal to on the right. So conclude that limit fx as x approaches 1 is equal to 0. It exists and is equal to 0. Therefore, conclusion for the step 3 is step 2 equals step 1. Limit fx as x approaches 1 equals f of 1 is equal to 0. Okay, and therefore conclusion is f is continuous at x is equal to 1. Okay, settle. And this is the graph. Okay, for absolute value when f(x) is equal to modulus x minus 1. This is that one. This is gradient negative. For this part is gradient positive and 0 here. Okay, this graph is continuous. Okay, and then for differentiable, need to follow the two steps, right? And then the first step is done. Okay, from the first part, f is continuous at x is equal to 1. So then, okay, the second step is need to show f prime is continuous at x is equal to 1. So need to follow the three steps also. And then here is actually when this function differentiate to find the first derivative. Okay, so f prime of x is equal to differentiate x minus 1, get 1. For x more than 1, differentiate negative x minus 1, also get negative 1 for x less than 1. But the problem is when differentiate 0, so we don't know the value. There is no value actually. Okay, so we don't know that one. And follow the three steps. F prime of 1, actually we don't know the value. The value actually no value. Okay, and if no value, okay, can conclude f is not differentiable at x is equal to 1. Let's say if you want to follow the second step, limit, okay, as x approaches 1 from left, that is negative 1. That is negative 1. And limit when x approaches 1 from right, is 1. So this is actually not equal. So the limit when x approaches 1 does not exist. For the third step is f prime of x is not continuous at x equals 1. It implies that f is not differentiable at x equals 1. So this is the graph. For x more than 1, the graph is 1. Okay, this 1. Okay, when x is less than 1, the graph is okay, 1. And here, no value when x is equal to 1. So actually from the graph, it shows that f prime of x not continuous. Not continuous. For this example, this was function f(x) when x less or equal to 1, and the function is x squared when x more than 1. Discuss the continuity at x is equal to 1. So for the continuity, need to satisfy the three steps. First is f of 1, substitute 1 is equal to 1. Okay, and the first second step, limit, okay, x approaches 1 from left. Here, get this function and substitute, get 1. And limit as x approaches 1 from right, okay, choose this function, substitute 1 and is equal to 1. Therefore, limit f(x), x approaches 1 is equal to 1. And the third step, step 2 equals step 1. Limit f(x), x approaches 1 is equal to f(1) or 1. Therefore, f is continuous at x is equal to 1. Conclusion for continuity. Okay, and okay, for differentiable, this function differentiate for the first derivative to find f prime of x when differentiate function x at 1 for x less or equal to 1. Differentiate x squared at 2x when x more than 1. And discuss differentiability at x is equal to 1. Okay, the first step, okay, f is continuous. Okay, done. And the second step, we're going to check whether f prime of x is continuous. Follow the three steps. First, f prime of 1, here, substitute and 1. And the second step, limit x approaches 1 from left, okay, here, and 1. Answer is 1. And when limit x approaches 1 from right, in this function, substitute and 2. The answer is 2. Okay, since limit f prime of x as x approaches 1 from left is not equal limit f prime of x as x approaches 1 from right. And conclusion, limit f prime of x as x approaches 1 does not exist. Okay, and the conclusion is f prime is not continuous, okay, at x is equal to 1. Okay, and conclusion, f is not differentiable at x is equal to 1. Okay, this is example for continuous but not differentiable. And here the graph. Okay, for the function fx, the graph looks like this. Okay, the graph is smooth. Okay, from here to here when the graph is zoom in the graph. Right, so the graph is continuous at x is equal to 1. Okay, and zoom in. Okay, this one to show that when x is equal to 1, the graph is continuous. For graph f prime x at x is equal to 1, the graph is discontinuous. Okay, so this f prime of x is continuous and f is not differentiable at x is equal to 1. Okay, for this example, function fx, x cubed plus 3 when x less than 1, 3x plus 1 when x greater or equal 1. So for continuity at x is equal to 1, okay, we follow the 3 steps. First step, f of 1. Okay, substitute this function 3 times 1 plus 1 is equal to 4. For the second step, and the limit. Okay, limit. Okay, for x approaches 1 from left. Okay, here the function is x cubed plus 3. Substitute 1 plus 3 is equal to 4. For limit as x approaches 1 from right, this one, we choose this function 3x plus 1 cubed 1. 3 times 1 plus 1 is equal to 4. Therefore, limit fx as x approaches 1 is equal to 4. So follow the 3 steps. The third step, number 2 is equal to number 1. So limit fx as x approaches 1 is equal to f of 1 is equal to 4. And conclusion, f is continuous, okay, at x is equal to 4. Okay, and for differentiability, okay, this function, okay, differentiate this function for the first derivative, okay, then, okay, f prime of x, differentiate x cubed plus 3 is equal to 3x squared for x less than 1. For x more or equal 1, differentiate 3x plus 1 is equal to 3. So this is the function of f prime of x. And to check the differentiability at x is equal to 1. Okay, the first step, this one, okay, f is continuous at x is equal to 1. Done. Okay, for the second step, we're going to find f prime of x. And to check whether that one is f prime of x is continuous or not. Okay, for follow the 3 steps. First step, f prime of 1 is equal to 3. Okay, yeah, is equal to 3. And then the second step, limit as x approaches 1 from left, here, substitute 3x squared, substitute 1 is equal to 3. When limit as x approaches 1 from right, okay, here the function n is equal to 3 constant. Therefore, limit f prime of x as x approaches 1 is equal to 3. Okay, and the third step is, Okay, step 2 equals step 1. Limit f prime of x as x equals 1 is equal to f prime of 1 is equal to 3. Therefore, conclusion, f prime is continuous at x is equal to 1. And conclusion, f is differentiable at x is equal to 1. Okay? And this is the graph. Okay, for fx and f prime of x. Okay. For fx, that is when x less than 1, x more or equal 1. This is the point 1. And this graph is continuous at x is equal to 1. Okay, for graph f prime of x, okay, this graph is continuous at x is equal to 1. Okay, the graph is continuous. So for differentiable, okay, and by looking at this graph, this graph, we trace the graph is smooth, means that differentiable.